This is UBC iGEM, and here we're talking with President Santa Ono at the UBC Point Grey campus.
What inspired you to pursue science and a career in academia?
I think it all began when I was, when I was a kid, I just liked trying to figure out how things work. I was very interested in living organisms. I was one of those kids that had petri dishes and looked at paramecia, had a microscope and looked at magnifications of all kinds of different structures, crystals, and living things as well. And I had a couple of great teachers, one in the 8th grade and one in the 10th and 11th grade in high school, and they went the extra mile. They spent money from their own pockets to buy equipment that didn't exist in our public schools so that I could do experiments, and drove me around to the local university that was Johns Hopkins University, and got to hear from Nobel Prize winning professors there and got really excited. At that time, biotechnology was really in its infancy. Restriction enzymes were discovered by two professors at Johns Hopkins University, and genetic engineering, recombinant DNA technology was really at its infancy, and so it was portrayed as the thing to do if you were a young person, much as neuroscience is now, and so I decided to study that at the University of Chicago, and I loved it there. I went to the University of Chicago because Jim Watson, one of the two scientists that determined the structure of DNA, went to school at the University of Chicago, and I read his book, The Double Helix, and I wanted to go to the same school where he was an undergraduate, and so all of that influenced my decision to go into biology and eventually to graduate school at McGill University.
Do you feel there's a stigma against using genetically modified organisms?
Way back then there was. In fact, I did a postdoctoral fellowship in biochemistry and molecular biology at Harvard University. And after restriction enzymes were identified and people started to make recombinant genes, recombinant DNA, they were actually banned from doing those experiments in Cambridge, Massachusetts, because the committee of citizens there felt that it might be dangerous, that recombinant DNA molecules might mutagenize humans and might be aerosolized, and that they might not be safe. And so recombinant DNA use, even for medical reasons or to make better salmon or better crops, was something that was really viewed with tremendous suspicion. Now, if you fast forward to now, in 2017, there are a lot of people that are treated with recombinant molecules, that, and the biotech industry is very mature. Back then, the very first biotech company, Genetics Institute, founded by Mark Potashny and Tom Manietis, one of the first biotech companies, was very small, and there were only a handful of such companies, and it was all viewed as something sort of space age, and people weren't sure it was really going to materialize. Now you have most major pharmaceutical companies and lots of larger biotech companies like Genzyme that really are very large. There are tens of thousands of employees working in these companies, and people are being treated with medicines that are a result of the biotech revolution. So I'd say that there isn't that much suspicion relative to the birth of the whole industry. There's still some, but compared to the beginning, and in Britain there was an entire commission. There was a recombinant DNA advisory committee in North America and the United States as well. And so we've been through all of that, and I think that the general public is not very suspicious of that.
Do you know of any current members or alumni of UBC that are involved in the biotech industry?
There are too many to name in one interview, but I'm going to mention two giants, or actually three giants in the field. One of them, unfortunately, isn't with us anymore. He's one of the Nobel laureates, Michael Smith, who really pioneered how you actually mutagenize DNA that was very, very important in designing molecules that might have a higher affinity as a receptor-ligand interaction, and he really pioneered that. And he trained many scientists that would found biotechnology companies, and so he had a transformative impact on the field. Before that, there were a whole slew of both chemists and biologists that have been involved. Two in particular, the largest biotech company in Canada, Stem Cell Technologies, is an outgrowth from UBC. Professor Eves is the founder of that biotech company. And the other person who's really a giant is probably one of the world's pioneers in stem cell regenerative medicine. And he's moving from the University of Toronto to UBC as we speak, Peter Zanstra, and he's going to be the founding director of the School of Biomedical Engineering and new director of the Michael Smith Labs, where he got his PhD. So those are a couple examples, but there are many, many more.
What do you think can be done to encourage startups and the biotechnology industry in Vancouver and British Columbia?
Well, that's one of the things that I've been working on as the Premier's advisor on innovation. And we've been trying to build a foundation for more startups a number of different ways. First of all, UBC is critical to the future of biotechnology in Canada. 90% of the research that occurs in this province occurs at UBC. So we have to get it right at UBC for it to really happen here in Vancouver and British Columbia. So one of the things that I asked my executive team to think about is how to support scientists and students better in terms of innovating in terms of biotechnology. And so we're about to announce a number of initiatives to reconfigure how we support faculty and students in terms of innovation in biotechnology, but in terms of all sorts of science that has an applied possibility. And one of them will be the creation of a set of innovation hubs around campus, one here in Point Grey, one in Robson Square, perhaps another one closer to the St. Paul's Hospital. So one of the ways is to really think about infrastructure. Scientists need to be able to go to a place and collide with each other, to think about, talk about what they're doing, and through those conversations, new ideas emerge. So physical space is one way to do it. The other is to take a look at who we have working with our scientists. We're hiring serial entrepreneurs, because it's one thing to be a brilliant scientist in the laboratory. It's another skill set to understand how to raise money, understand issues of intellectual property, understand regulatory issues and what it takes to go through clinical trials in the United States. And that's a very complicated set of skills that a typical professor or student doesn't yet have. And so our job is to provide that team around them so that they can be successful in the very competitive landscape of launching a company. So space is one. Second is really a comprehensive strategy of providing support for our faculty, staff, and students. The third has to do with money, because it takes a lot of money to start up a company. And one of the things we're doing in British Columbia, but also across Canada, is taking a look at the assets that we have. And one of my jobs as the Premier's Innovation Advisor is to actually do a gap analysis of how we're doing in British Columbia, how we're doing at UBC, how we're doing in the whole post-secondary sector, how we're doing across Canada, and where do we have gaps in the ecosystem or the pipeline of innovation. And we're doing that together with a number of consulting companies, and we're releasing some of that information. And so that's another way that we're doing it. The third way is that I've had to play a lead role in thinking about British Columbia's strategy. The national government has released a competition for about $950 million in funding. And the deadline for submitting letters of intent has passed. And UBC put together really, I think, one of the most competitive proposals, British Columbia, not just UBC. UBC plays a big part. It's industry-led. We've put in a letter of intent around data science, data technology, and utilizing our strengths in the Internet of Things and in quantum computing, and virtual and mixed reality, augmented reality, that will have an impact on everything from biotech and healthcare all the way to mining and forestry. So that's a third example.
What are some issues that you think could be addressed using synthetic biology?
Synthetic biology is something that I care about a lot. It is something that will be almost certainly the focus of the new school of biomedical engineering, bioengineering. And it comes in very different forms. It has to do with synthesizing new molecules, new enzymes, which really is based upon recombinant DNA technology, but also involves using new approaches such as CRISPR technology, or creating biological motors and molecules and engines and things like that. And so there are just a vast number of possible applications of synthetic biology. I participated in this thing called the Keck Futures Initiative, and there's a book that we published about synthetic biology. It was a collaboration between the National Institutes of Health and the Keck Foundation. So you can look it up. There's a book that exists, and we got together in teams, teams of medical scientists, doctors, engineers, and biomedical scientists, and ethicists to think about what the future of synthetic biology would look like. And it has everything, to answer your question, there are many different possible applications, all the way from artificial intelligence to creating approaches to combat infectious diseases in humans, in agriculture, in forestry, in oceans. So the potential of synthetic biology is really vast.
There's so many students at UBC. How can a student stand out and get involved?
Well, it depends on what you mean by stand out. One way to stand out is so that everybody here on campus knows who you are. And there are different ways to stand out locally. You can be very prominent in publications like the UBC or undergraduate research journals and things like that are read primarily here, even though they might be online. So that's one way to be prominent and stand out here. There are ways that you can talk to faculty members and deans and administrators about what you're doing. That's one way to be prominent here. If you want to be prominent and stand out nationally, say provincially, there are opportunities to volunteer. There are lots of committees at the university, at the province level, nationally, that would welcome your involvement. And that's one way to stand out, is by speaking up and talking about what's important to you and to provide a student perspective. So that's one way to stand out. In terms of individuals interested in biotechnology or applications of new technologies, in terms of progress in society, if you will, one of the ways is to contribute to a seminal discovery, to be working in a laboratory and publishing that. That's disseminated through journals, and that attracts attention globally. So that's one way to stand out on the global scene. So it really depends on what you want to do, and it's possible to do all of them, or it's possible to focus just on one.
This year's iGEM project is to design a CRISPR system that will conjugate through a population of virulent bacteria and disarm them. These bacteria cause tumor growth in economically important plants, thus decreasing the yield of farmers. What do you think about our project?
My thoughts are, first, it's amazing how quickly students have been involved, have harnessed the technology for an application, because it's not that long ago the CRISPR technology really rolled out. Many of the scientists that were involved in that are much younger than I am, and it didn't take a lot of time for students and young faculty members to try to leverage that for applications such as the one that you're involved in. So the first thought is amazing how quickly you guys are get to work, and second, I'm excited the fact that you're using something so sophisticated to tackle an important issue in society. Third feeling I have is that I can't wait to see how it's going and learning more about what you're doing. And the fourth thought I have is how can I help you? Because it's not easy to translate what you're doing as a project to the market. As I said, there's all kinds of issues in terms of is there an intellectual property aspect? What kind of financial support might you need from the institution to launch it? If you're going to launch it, are you thinking about creating some kind of company around it? And so the last thought I have is that hopefully you and other members of the project won't be shy to talk to me because I have direct experience in those sorts of things. So I think it's cool, I'm excited, and I want to help.
Any words of advice for aspiring scientists?
I think it's the best life that anyone can choose. I like playing music too, and I like playing basketball, and those things are part of my contentment and happiness. But a career as a scientist is amazing because, although it's also difficult, you spend a lot of time in the lab, and things don't always work, and can get to you. But if you can be part of an innovation, it's a contribution not only to people who are here right now with you at the same time, but as you can see, talking about these pioneers that I mentioned, Dr. Eves, Peter Zanstra, who was not that long ago a student like you are, he's pioneering regenerative medicine approaches, scaling up stem cell expansion, modification in vitro, that I truly believe will be cures for diseases that are incurable today. And if you can be part of that, it's incredibly fulfilling. And you can then say, when you go to bed at night and you put your head on the pillow, I've done something significant. So it's an honor and privilege to be a scientist. That's what I would say.
What can we do as students to help better communicate science to the public?
Well, what you're doing now is one way. The tools that you have to communicate now didn't exist when I was your age. We had no email. We certainly had no internet. We certainly did have YouTube, where you can actually own a YouTube and have millions of viewers. So you can communicate at will in a way that we couldn't even dream of, and instantaneously. So the fact that you're videotaping this interview, I hope you're going to be using multiple channels to get the story out. You should keep doing that because you can communicate better than we could, as I said, even dreamed of. So I'm jealous.